In graph theory, we say that a directed graph is a strongly connected graph if there is a directed path from every vertex to every other vertex. So let's consider this directed graph right here. We know this is a directed graph because each of the edges in the graph have an arrow on them indicating which direction they go in. So for example, if we consider this edge right here, we can see that the arrow on this edge is pointed to vertex A. So in other words, this edge is going from vertex C to vertex A. So there's a specific direction associated with the edge. And we can see that all of the edges in the graph have an arrow on them indicating their direction. So that's how we know this is a directed graph. Now, to determine if this is a strongly connected graph, we need to determine if it's possible to go from every vertex in the graph to every other vertex, just by following a sequence of edges. So for example, if we consider vertex A, is it possible to get to every other vertex in the graph? Well, let's see. We can get to B by following this edge, since this edge is pointed towards B. We can then get to vertex D by following this edge. We can get to vertex C by following this edge, but we'll notice there's no way to get to vertex E up here, because both of the edges, these two edges that are incident with vertex E, are going away from vertex E. So there's no way to travel to vertex E from vertex A. So right away we know that this is not a strongly connected graph, because we can't get from every vertex to every other vertex. Consider if we flipped this arrow right here. So instead of this edge going to C, let's flip it around and make it go to E. So if we flip this arrow around, we'll find that suddenly it's possible to go from vertex A to every other vertex, because we can get to B, D, C, and now we can get to E. And what we'll find is that this is actually now a strongly connected graph because we can get from any vertex to any other vertex. So for example, if we consider vertex B now, can we get to every other vertex? Well, we can follow this edge to get to vertex D. We could follow this edge to get to C. We could follow this edge to get to E. And once we're at C, we could also follow this edge to get to vertex A. So we can go from vertex B to every other vertex in the graph. And what you'll find is that the same is true for the remaining three vertices. We can get from each of these vertices to every other vertex in the graph. So now this is a strongly connected graph. So that's what we mean when we say that a directed graph is a strongly connected graph. It just means that we can get from every vertex to every other vertex in the graph.